Yo, it's good. Oh shit! I need this actually. Sorry, my camera's getting left behind on this desktop. We want it over. Oh shit. Okay. Bear with me, guys. Definitely leaving this in there. Alright, here we go. Yeah, you can already see I kind of got to some work here. It's basically like I realized that any video of me like actually trying to live code something's a fucking disaster. But that's why we have the Jupyter Lab, because we can just do what you're seeing here. You know what? Actually, I'm gonna make this look a little bit. I don't know. I feel like I'm not feeling the dark background today. You know what I mean? Sometimes I just gotta switch it up because it's really hard to see. Oh my god. Alright, so basically, before I start actually showing this, we'll come back here. Ooh. So, what am I doing? What the hell are we doing? Why are we making a video? I actually already made one, and it sucked because I ramble for too long, so let me make this quick. Basically, I'm a musician, I'm a programmer. Basically all I have really going for me. It's a lot, but it's cool. They're also really hard to merge when it comes, like, as passions, so, I've been playing guitar all my life. Music's very important to me. Sound is very important to me. And I'm a programmer, and I haven't been doing that really for even really a fraction of the time that I've been playing music, but it's not maybe just as important, but I guess it's just as important in another kind of way. There are two different aspects of my life that really have never been merged or I guess unioned in any way. Just because they seem kind of like, it seems like there's a lot of like differences between them, like you think of like techie shit and you think of just like, digital number stuff, and, guitar is like sort of organic, and I don't even know where I'm going with this. Basically, it seems hard to merge them, but I found a way, and it was by learning a little bit more about synthesizing audio, like just digital audio synthesis. So I'm used to producing sound acoustically with. I gotta show her off real quick. Where's she at? Oh yeah. Anyways, but like I wanted to like what's the perfect way to merge programming and my love for just audio in general, and that's like, whoa, what if I just made audio with lines of code? And I started delving into it, and it's a rabbit hole in of itself. It's definitely like on the engineering side of programming, like it's like it's not really it's a totally different animal from like what I normally do, like what I currently do for work actually. It's really interesting because it's sort of it's actually like made me like have to use math again since high school, because like being a programmer, I think we use more math now. Like really, like I avoid using math, but sound is very, very mathematical. As you're about to see, actually, this I'm gonna try to go through this kind of quick, because so like basically like the most elementary form of sound that you can produce, I guess digitally, really acoustically, all sound is a wave, and a wave has to occupy a duration, and it's got to have amplitude, and it's going to have a frequency, that being the amount of cycles per period of that wave. And a sine wave just happens to be like the go-to, like it's like the Goku of trigonometry. I don't know what that means, but so basically, how do we do this like with the computer? Because like EDM is like kind of made a very, very large impact on modern music, and most, if not all, almost all music has a it's some degree of synthesized audio. Somebody has to write the code for that, and normally like we just see it like on Ableton or Fruity Loops and like all that shit, and we just press a button and it's kind of done for us. But really, there's still an art form to how it's done, because like you can't yeah, we're kind of pulling sound out of our ass, but we literally have to, we have to tell the computer, okay, I want you to imitate this acoustic, organically, like organic thing that is a sound wave, and I want you to do it with 16-bit unsigned integers. Basically, just do it in binary and then play it through your fucking speakers. It's very capable of doing that. You're hearing me right now, like speaking, and although you're hearing my voice, you are still just hearing some 16-bit unsigned integers in an array. And what is an array? Array is basically it's like a matrix. It's a fucking table of numbers, and it has a shape. So you can have a matrix that is like 3 numbers by 3 numbers, or we can have a matrix, for example, that is I guess whatever 3 times 44,000, that many samples long, and and then like the height of it is the maximum amplitude of our wave. So I probably already lost you guys here, but that's okay. Basically, here, you like my little notes here. First, we gotta get some shit straight. If you want to generate a sound, just a basic form of sound, you need to know your sample rate, which is how many samples per second your wave is going to have. So that's how many literal elements in the fucking array are going to be there. How much can we divide a second, and get as close as we can to the thing that is an acoustic analog wave, because analog waves aren't divided into anything. We need to define the duration, obviously, for the same reason we just define the sample rate. We need to know how many total samples it's going to be. Then we also need to define, my sister being all loud, it's fine. We also need to define the frequency, I guess in this instance, because we're kind of doing this by hand, doing it the hard way, so you can see. So I'll just start with 800, no, we're not doing 800 hertz, it's going to hurt you guys, sorry. 440, good old A. Define that as a float. So then we need a line, but with numbers. So NP, this thing we're seeing here, yeah, that's a short, it's an abbreviation for NumPy, which is a very, very handy library for anything that is I guess really math in general, but it's mostly for doing mathematics with arrays of numbers, and treating them as just individual, variables in a equation, formula, whatever. I hope that makes sense. I'm bad at explaining this kind of shit, but so basically, NumPy has a function called a line space, and it's takes 3 arguments. If you can't tell, they're separated by 3 commas here. 2 commas, but there's 3 arguments. First one, start. Where does it start? It starts with 0, because that's the beginning of our note. The second one is going to be how, the step. So how are we dividing it? How many, not how many, but what is the length of each element that this line space is going to be divided into, and that is your individual samples. So basically it's actually just going to be the duration of your note times 2 times pi. You're already probably having some trigonometry flashbacks. Anyways, that don't matter. Last one is the stop, the end of your line space. How many total elements to divide into that length will there be? And like I said before, it'll just be the duration, the seconds times your sample rate. That's samples per second. Cool. So we have that, and that's basically our canvas that we can paint we can take any frequency and generate a wave on that is 3 seconds long on that particular line space, because we made it so. So you can see here, sine wave is going to basically just be the sine function of the frequency multiplied times that array. So literally multiplying 440.0, which is 440 hertz, multiply that times, I guess, not every element. What do we have every element? You're multiplying it times an array. It's complicated. You're multiplying it times literally thousands, millions, I don't know how many numbers, a lot. Wait, don't put the shit button, attenuate it first. Also, when you generate So if I would have just played this wave that was just generated here, I would blow my speakers and definitely piss more than a couple people off. So what we do is we attenuate it, and we basically say the sine wave is going to be equal to the sine wave, but multiplied times like a fraction of itself, because you don't want to play raw audio that you just synthesized. You have to tell things like to quiet the fuck down, or else it'll just use all your power. Like, you can still turn your volume up and shit, but it'll be too loud still. So cool. Knew that. Wait a minute, I should just run all these actually. Boom, 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 boom. And now, if we play it, yay, it's just a sine wave. Literally nothing more, it's just a fucking sine wave. Just a tone. It gets more interesting, don't worry guys. Here's actually, if you, I don't know if y'all are interested in this, but we can actually plot it. Pretty cool. It's not that cool because it's just a sine wave. But, yeah, so playtime is motherfucking over, because it's time for some motherfucking frequency modulation. What is modulating frequencies? I could explain that to you, but I think we all want to have a good time. But all you need to know is, before we define the frequency for a sine wave, this time we also are going to define a second frequency. Basically what we're going to do is we're going to take that same sine wave, but we're going to modulate it by that second frequency. And the factor too is like how much we're willing to actually modulate each cycle of the wave. Pretty cool stuff. Yeah, the other one's too short. Yeah, so basically we need to generate a second line space too, because we changed our duration here, so it's whatever metrics. So now we did what we did before, but basically, to put it in a nutshell, it's like, here's a wave for the wave, so it can modulate the wave while you wave. And I wish that was like, me joking and trying to explain this, but it's actually probably the best thing I got. But what matters is that you can hear it, so this is what that sounds like. Awful. But both of those were originally, both of those are 440 hertz, except this one we're modulating it by 430 hertz. And it looks pretty cool if you actually plot it. It's like, yeah, it's cool. So basically, you can see that there's like, it's almost as if there's like a second wave, like fighting it or modulating it. It's basically what's happening. Look, I'm learning as I'm like explaining this. It's crazy. Yeah, I was trying to make some space. Oh yeah, look at this though. So this is where it gets pretty interesting. This is actually where we start getting into like genuine audio synthesis. Because usually like when we design like in Ableton, Fruity Loops, and like all these like modern softwares that people use to make music, somebody actually has to design or code the pads and like the modules that you'll be using. So like if you have like all these different sounds that you can like play on your keyboard, and you just have like a whole fucking plethora of them, like all of those are basically going to kind of be based off of like what we just did here, but as like a form of art. So you can modulate frequencies by any frequencies, or you can modulate the wave that is modulating your wave by another wave, or we can actually modulate it like as a function of time using a log space, which is basically a ramp, similar to our line space that has our wave in it, but we want a ramp so that way we can sort of like crank up the frequency modulation over time, and it sounds pretty fucking cool. So you just start like combining these things and like just tinkering with them, and there's infinite ways to manipulate these waves. And this is just sine waves. There's triangle waves, square waves, sawtooth waves. We'll get there. But yeah, it's like that's why there's like a new ramp variable. Yeah, line space got a new homie. I need to get my face out of the fucking way. Get out of here. Yeah, it'll ramp though. So yeah, just throw the ramp anyway, basically, but don't really. Right here, you see that it's similar to like when we generate the sine wave, but we're basically just throwing in like an extra sine wave, and adding it by some fancy stuff. how to play that shit, DJ. So that's what this sounds like. Yeah, it sort of sounds like a 1990s sci-fi. And then we could plot it, but it's actually pretty fucking boring. So, yeah, that's pretty much it. I know y'all probably expected this to go further, but I feel like we're kind of crunched for time. You guys are probably already losing interest. But before you go, let me show you what this is where it started out. I guess this is where I started with audio synthesis, is what I just showed you. I had to really get familiar with this math, and I really still don't understand a lot of it, but I understand it enough to work with it and be able to read the code and be able to manipulate the code and write code that can be implemented in ways that are actually useful, because what we just did is cool, we generated tone, but that's not interactive or useful. So let me just go to my handy dandy thing right here, and don't go yet, please. This is the one thing I'm pretty proud of. Okay. We need Orca 2. Yeah, I like the version 2.0, 0.2. So this is what I've recently built, and I'm not gonna take credit for this the code that this is based on, but it is my own project that I'm working on, and trying to implement some of my own features and shit into it, because it's pretty cool. Basically, my keyboard is now a synthesizer, and these are basically just adjustables that I've set. So all those things you saw me those variables you saw me defining as constants when I was showing you guys just now, these are now basically manipulatable by the fly. This is a very complicated implementation of what I just showed you guys, because I showed you guys literally one layer of frequency modulation of a sine wave, and this is even if we turn all this shit down and have no effects, it still has envelope shaping, so there's kind of a taper off to the sound and shit. A lot of work goes into just the simplest shit, but it's pretty cool. But if you turn this shit up, oh, that one's not that interesting. Hold on here. And if you really want to annoy people, you can just. But there's also a stop button. Also, you guys might not be able to hear it because shitty speakers, but I'll actually put this in the description so you can download it if you want to fucks with it. This delay thing right here. You might not be able to hear the difference right away, because it's on my speakers, but delay sort of creates a dissonance between the left and the right channels. It sort of slightly offsets them and gives it it creates the sense of stereo spacing. So it actually when I was doing it with my headphones earlier, and it literally pulls the sound out to the side as you slide that slider up. Pretty fucking cool. I really like doing the low ones. Oh, that's fucking stupid. Probably can't even hear that, but yeah, and you can tell that I don't do a lot of graphical or GUI programming because it's just awful. But I might make it look nicer eventually. I really don't care how it looks. It just needs to function. But anyways, I guess that's really it. I don't want to go though. I like talking to you guys. Anyways, I was trying to think of something else that was relevant, and I really ain't. Not anything that I have ready at the moment. Well, actually, while you guys are here. Oh wait, it's in the For Gary folder. Don't ask, it's a long story. Oh yeah, so what I was showing you guys earlier, that was all sine waves, and basically we can do, there's like other kinds of waves too, so you have a sine wave, which is just like a normal wave, and then you have, God, I wish I could actually like show you a plot of one. Yeah, I can actually. Then we have triangle waves, which is literally like, you know, it's like a triangles. And then we have square waves, which is exactly what it sounds like, and then sawtooth waves, which they're kind of like that. There's also reverse sawtooth waves, and the way they're generated is like, it still uses like an array, you know, the line space and all that, except it's like, it just has a completely different final like wave function. Like instead of using the numpy sign, you can see we have like 2 divided by pi times arc sine of the sine of the frequency times the array plus the log ramp multiplied times a sine wave attenuated. Wait, yo, you know what? I should just plot this actually. I'm gonna show you guys what it looks like real quick. Because I can just modify my own code. Here is what you guys want to see, right? So I'm going to format plot is plot, so we can actually visualize it. I want it to look dark. Right? Come back, not grand. That's cool. Make an error. Alright, cool. So plot data equals wave. Oh wait, no. Result. I'm gonna do like 1500, I guess. 1000 actually. And then we're going to fig x equals plot. Subplots. Hurry, times like the s's. And then we'll plot the plot data. Set the line width so you can actually see it. I don't know why I did that. We don't need that. This is a modulated triangle wave, so it's gonna look really crazy, but I just wanted you guys to see the drastic change in waves. I think it's cool. I'm a fucking nerd and bored, and it's the plague, so everybody's bored. Okay, yeah, it should be good. Now let's run that now. Sorry about that, but I'm fucking proud of that. Yeah, it's definitely not a triangle wave. It's a fucking travesty. No, it's beautiful. Basically, what I did is, you can see at one point it might have possibly resembled a triangle wave, but yeah, see, it's triangles. But we modulated, and that's why you see this sort of like. You see this like this fucking weird. I just think it's interesting to like seeing visually what our ears are hearing, because like you're hearing texture, and texture is definitely like important, especially in modern music. So this is like an art form that I think goes pretty unappreciated, you know. So word up to all the people who are a little bit more well versed in you know, this field than I am, but I'm trying to get there, and I have the tools. It's fun being a programmer. Until it's not. Then it just gets lonely. Anyways. Yeah. Now I'm just wasting fucking hard drive space. Somebody stop this video, please.